The early explorers, traveled across oceans, traveled to the poles of the earth, basically to find this out, to see if there's anybody else there like us, to see whether there are any roots of our civilization elsewhere. But we're now at an age where we can go even further. This is our Earth. It's taken from space. It's a beautiful blue planet. It's something that we love. But we also would like to know whether we're alone in the universe, whether there are elsewhere planets such as this. And that's actually a big field now in astronomy and in agencies such as NASA, which set goals like this as part of their label. Now, obviously the first place to look is in our solar system. Here is a solar system not to scale by distance from the sun, but by scale to size. You can see the Earth is kind of small compared to some of the planets. One of these will work. This is high technology. The Earth is kind of small compared to the other planets. It's kind of bluish. It's much smaller than Jupiter, Saturn, Uranus, and Neptune, but it is unique. And we know it's unique because as of now, we haven't found any other people in it. So let's see whether any other planet in our solar system looks like us. Well, what are the characteristics of a planet? Well, it's the composition of the planet, the pressure on the surface of the planet, its temperature, its winds, basically its meteorology. The size of the planet, its orbital dynamics, how far is it from the sun? How far is it from this source of all energy for all the planets? And also, how fast does it rotate on its axis? These are all parameters that define a planet. And of course, when you look at the surface of a planet, if it has a hard surface, you want to know about its topography, its plains, lakes, whether it has any fluid on its surface. So we can look for that. We know that other planets in the solar system have very similar phenomena, because many of these phenomena are controlled by physical laws. So for example, hurricanes. Here's Katrina. That we know how terrible that is. But when you look at a similar hurricane on Jupiter, this is the Great Red Spot, which is larger than several Earths. That baby is really, really rough. We have similar storms on Neptune. So you have similar phenomena, at least from a distance. We know that there are beautiful shining lights in the north, the aurora. We have beautiful pictures of them. We can take their picture from space. You see around the North Pole, there's this beautiful light that can be seen from spacecraft orbiting the Earth. But if you look at Jupiter, using the Hubble Space Telescope, you see very, very similar phenomena. It's because both have a magnetic field, both have an atmosphere, and the atmosphere in both attracts particles from the sun, precipitating into the atmosphere and causing them to excite molecules in the atmosphere, much the same way as fluorescent lights light up in your study or in your office. We can also look for lakes on the surface. Well, here's Lake Superior. Well, if you go to Titan, which is a moon of Saturn, you find lakes that are very similar. The only difference is this is water, and this lake is liquid methane. It's the same gas that you use to heat your house, the same gas that you use to heat your food, but it's all in liquid because Titan is very far away. It's 10 times further away from the sun than the Earth. So let's look and see what else. There's the atmosphere. The atmosphere is an important parameter that defines the Earth. Now we've, I think, excluded Jupiter, Saturn, Uranus, and Neptune as planets that are not like the Earth because they're so-called gas giants. Most of the mass in these planets is gas, so it's not like the Earth. But planets, there are planets that are called terrestrial planets, and they have a solid surface, and they may or may not have a planet, an atmosphere above them. Mercury, there's a mission to Mercury right now, Messenger. It's detecting an atmosphere, but the atmosphere that it detects is maybe more than 10 million times lower pressure than on the Earth. Not very much of an atmosphere. Pluto, it's too cold to have an atmosphere. If there is any gas out there, and if you believe it's a planet, it's got no atmosphere. So we have Venus. Venus has a very dense atmosphere, but it's so close to the sun, it's very hot and very dense, and so the temperatures are such that no living creature can really survive on the Earth except if you're made out of something that's harder than lead. And then you have Mars. Well, Mars has a pressure that's only 1/10 that of the Earth. But many of these major three terrestrial planets, and I include another object here, Titan, which is a moon of Saturn. I already showed you it has lakes. And actually Titan is very interesting because it is very much like the Earth, and I'll say more about that. But if you look at the composition, Titan is mostly nitrogen's atmosphere. The atmosphere of Titan is mostly nitrogen. That's very similar to the Earth. Mars is mostly carbon dioxide, very different from the Earth. So now, if you want to use an atmosphere of a planet to identify whether it's like the Earth, what do you look for? You look for the composition of the Earth, the atoms that make up most of that planet. Well, these atoms, oxygen, nitrogen, carbon, and hydrogen, make up most of the universe. So that's not unique. But then you look at the molecules. And what do you look for? You look for oxygen-bearing molecules, such as ozone. You look for methane or ethane. These are molecules, hydrocarbons, that are actually products of biological activity. Ammonia, also containing nitrogen. Ammonia compounds play a role in the formation of proteins. So again, this has implications to life. Carbon dioxide. Carbon dioxide is, for us, a pollutant. It's causing global warming. But at the same time, it also keeps the atmosphere of our planet warm enough that we can exist without freezing or being in a very uncomfortable environment. And of course, water. We know there's water throughout the universe. The question is, what form is the water? What makes it unique? Anybody know? If you were to ask that question, yes.
The only place that has me on it.
I've never gotten that before, but I like that. That's why it's unique. Liquid water. It's the only place, well, that we know right now in our solar system that has liquid water. We think there might be others. In fact, it lies at a distance from the sun, from our star, just far enough to keep it warm and just close enough to keep water from freezing in a so-called habitable zone. You see, other terrestrial planets like Venus are pretty close to it, but they're too close to the sun. It's too hot. You can't have liquid water. Mars, on the other hand, just skims that habitable zone. So Mars is an interesting planet to try to look for. There are three other objects that may have liquid water. One of them is Europa, and two of them is a moon of Jupiter, and Enceladus, which is a moon of Saturn. Now, these moons are quite huge. They're bigger than Pluto. But what these moons have are tens to hundreds of kilometers of ice. But it's believed that in the core of these, there is liquid, and it must be liquid water.